Now that we have done the angular momentum for a single particle, and that we had seen was equal to what? It was equal to, we denoted the angular momentum by L and it was a vector, and it came out to be R cross P. That is for a single particle. And obviously, as this chapter tells you, we are dealing with a system of particles, right? We are dealing with a system of particles and not a single particle, right? So, and that system of particles belong to a rigid body. So maybe it is something like this, right? So it is something like this, and there could be some axis of rotation like that, not necessarily passing through the middle, not necessarily. Okay, so you can define your own axis, but that axis, it can be rotating, but normally the cases that we will be doing there, the axis will be fixed. Okay, so you have to ensure that that axis is fixed and the body makes a pure rotation about that axis. Fine. Now let there be n particles, right? So let there be n particles in a rigid body. Okay. Okay. And I normally have my origin fixed somewhere. Not essentially here, it could be anywhere. Fine. But normally we take the origin to be on the axis of rotation. Okay, and so it is here. So what is my R? R becomes the vector that has got its tail at this origin and the head at the point which we are talking about. This is the practical application of R. Why you were taught about the R, which is a position vector, correct? Which is a position vector. So let there be n particles in the rigid body. So what happens? So their angular momentums, is a wrong word. Their angular momenta, right, are, okay, their angular momenta are what? For the first particle it is L1 is equal to R1 cross P1. Of course, all the three are vectors. L2 is equal to R2 cross P2. L3 is equal to R3 cross P3 dot dot dot. Nth particle Ln has Rn cross Pn. Correct? So this is what the angular momenta are. Correct? And the angular momenta, then the angular momentum itself is a vector. So obviously, if I want to find the total momentum, it will be the sum of the individual momenta, right? Correct? So the total angular momentum, and the total angular momentum is something that is always expressed in capital L, okay, to distinguish it from individual particles, correct? So that is the total angular momentum is the vector sum of the individual momenta. Okay, so L is equal to L1 plus L2 plus L3 plus Ln. Okay, plus Ln, and obviously they are R1 cross P1 plus R2 cross P2 plus R3 cross P3 plus Rn cross Pn. Correct? Now if I want to write it in the sigma notation, what do I do that? What do I do? It is sigma Ri cross Pi, and summation is from I is equal to 1 ends at I is equal to n. This is how we do that, right? That is my L. This is the total angular momentum, correct? Now if I want to find out the rate of change of angular momentum, whenever I say rate, it is normally with respect to time. Okay, so you say power is the rate of doing work. It means it is the work done per unit time. Correct. The velocity is the rate of change of displacement. It means it is change of displacement upon time. The acceleration is the rate of change of velocity divided by time. So I want to find out the rate of change of the angular momentum, right? The rate of change of the angular momentum L is what? dl upon dt, right? Right? Now the dl upon dt will be dl1 upon dt plus dl2 upon dt plus dl plus dl3 upon dt plus dl n upon dt. And what is this? Say dl1 upon dt we had found out is equal to ddt of r1 cross p1, which is nothing but r1 cross ddt of p1 plus dr1 by dt cross p1, correct? And dp1 by dt is what? This is the rate of change of momentum, which is force. So this is r1 cross f1 plus dr1 by dt is v1 cross p1 is mv1. r1 cross f1 is what? Tau. So I name it tau 1 plus m into v1 cross v1. What is v1 cross v1? These are two parallel vectors. The angle between them is 0. So mod v1 mod v2 into sine theta, theta is 0, sine 0 is 0. So this is 0. So it actually remains as tau 1. This we had already done. I am repeating it for the sake of recapitulation, right? So we had done this, that the rate of change of angular momentum is equal to the torque on the same lines as the rate of change of momentum is equal to force in translational motion.
Why have we written mv1 cross v1?
Because this is a scalar, no? So you know, we have this lambda A cross B is equal to A cross lambda B. Okay. So it keeps on flipping in and out, right? Commutativity, no. It's not commutativity. Don't mistake it with commutativity. This is not commutativity because the cross product is not commutative. A cross B is not equal to B cross A. It is minus B cross A. Minus B cross A.
Then how did it happen?
Scalar is coming in and out. It's not that I have taken MV1 here and V1 there. No, I cannot. I cannot commutate the cross product. It gives me the magnitude remains the same, but the direction of the vector changes. A cross B is not B cross A. Obviously plus 0, so it is T1. So dl upon dt, this becomes tau 1 plus tau 2 plus tau 3 plus tau n. Correct. And what is that equal to? That is equal to tau I is equal to 1 to n. Correct. That is equal to I is equal to 1 to n. So it is what? It is the sum total of all the torques. Correct? So it is sum total of all the torques. And what are these torques? They are these. So I am again reverting back.
Would there be a vector symbol over tau? Right?
Yes, it will be a vector. Yes. Okay. Okay. Now this Fi, that means this Fi is what? This is not that there is only one force there. So on particle number 1, say on this particle, there can be 3 forces. Say it has a tendency to rotate like this. So it may have maybe a force like this. Okay, this is particle number 1. It may be having a force like this. Okay, and then it may be having a force like say this. So what is F1? That is the vector sum, the resultant of all the forces that is acting on particle 1. Correct? So the forces F1, F2, F3, Fn, and they are all vectors acting on particle 1, 2, 3, n respectively is the vector sum of all the forces that are acting on that point. is the vector sum of all the forces acting on that point. Okay, acting on that point. Fine. Now these forces also, so there may be say 12 forces acting on one, so my F1 is the vector sum of that, so I collapse it into one, that I am quite capable of doing. Fine. So and it will be like that, you know, vector sum is not a joke. Okay, it is not some vague mathematical concept that was told to you. It has been seen to be following that rule that we have studied. That means if someone is maybe pulling it from here and pulling it from here with equal force, I'll actually start going forward with a force that is 2f cos theta if they are making an angle of theta with this, right? F cos theta, f sin theta goes away. Okay, it does not go away in the sense that maybe if someone is pulling me, okay, with my hands, my hand will also feel a pull in that direction, but overall my body will have no net force. So that's why it's not going there, it's not going there, because the f sin theta of this component and f sin theta of this component, they cancel. So it is a real thing. It is a real thing, and it's not something kind of just a vague mathematical concept. No, it is not. So what I'm trying to say, if maybe the sum total of all the forces, they are trying to push the particle or pull the particle in say some direction, say perpendicular or say in this direction, then the whole thing will start rotating like that. Understand? So it is that. Now all these forces, the F1, the F2, okay, the total force on the individual particle, that is composed of two things. That is composed of two components. Okay, the one of the components is the external force. Another component is the internal force. Okay, another component is the internal force. So do I erase that part, the left part? From here? Hope you have written.
Yes, sir.
Now what happens? The forces, so I am saying the forces F1, F2, F3, Fn have two components. F external and F internal. Okay, it has two components. External component that is actually externally applied, right? So maybe I tie a thread to one of the points and start pulling it in a particular direction. So I am applying an external force, correct? And the internal. What do you mean by internal force? So there could be a particle here, there could be a particle here. Now what happens? This particle gets attracted by this gets attracted by this, gravitational attraction. So we said that these forces F1, F2, F3, they have two components. One is the external component, that is being absolutely applied by the external agency. There's another component which is the internal component, which may be the gravitational forces, or it could be due to, say, some spring, okay, or anything of that sort. Now what happens? Internal forces, so let us try to discuss what the internal forces are. Internal forces are always equal and opposite to each other. Okay, so say something like this. So if this is F, this is minus F. Say if it's a gravitational force, so that's how it acts, is it not? Now let us say, or let me maybe erase it. Otherwise it will not be clear. So I'm reproducing the same thing here. And let's say this is my origin. So I designate this as R1 and this as R2. This is F, this is minus F. No, they are not perpendicular. I never said. They look like perpendicular, but they are not. It could be anything. Okay. So let's say maybe it's something like this. Let this be the origin. They are not perpendicular, okay? Not necessarily. So for some pair of particles they could be, not always, okay? Now let us try to find out the torque of the system, the total torque on the system. The system consists of two particles, okay? So what is the torque? The torque is equal to torque due to internal forces. Torque due to internal forces. So it is R1 cross F1, okay, plus R2 cross minus F, not F1, minus F. Now what does that give me? It gives me R1, what am I doing? Cross F1 minus R2 cross F. What is that equal to? This is F. This becomes what? If I take out F like this, this actually becomes R1 minus R2 cross F. Can you tell me what is R1 minus R2? Which vector? R1 minus R2 is a vector. Which vector is that?
F or minus F. Which one you are asking?
R1 minus R2.
R1 minus R2.
Which vector?
Positive F.
The vector that connects the head of these two vectors. The head of these two vectors such that its head is on the first vector and the tail is on this vector. So we get that. Now F and R1 minus R2 make an angle of F and R1 minus R2. How do I calculate angles when I am calculating a cross product or a dot product? You first make them co-initial. So F has to be shifted to itself, parallel to itself, and has to come here, right? Or you shift this. So, or you shift R1 minus R2. This is your R1 minus R2 vector. So what is the angle between, and this is your shifted F. What is the angle between R1 minus R2 and F? 180. Whenever two vectors are making an angle of 0 or 180, what is their cross product? 0. Because it is first vector into modulus of the first vector into modulus of the second vector, sine theta n cap. Correct. So the magnitude itself has gone to 0. So the torque becomes it's a null vector. Okay. This vector cannot be equated to a scalar quantity. That evidently means that the torque is 0. So what have I somehow proved? I have proved that any pair of the internal forces taken together and you find out the torque with respect to wherever your origin is, you get a value 0. So what happens? For every pair, it goes to 0. So what does it mean? It means that the internal forces do not generate any torque. The internal forces, they are not generating any torque whatsoever. I have shown only a pair of it. So there will be maybe a million pair. But whatever you do, you will always be doing the same thing. Is it not? And this cannot rotate the system. So I am saying that the internal forces, are not capable of generating a torque. Correct. So try to understand, it's not so complicated. I had something like this. I had this, so I'll leave this, I'll erase this, okay? I'll leave this and I'll erase this. So what happens actually, the total this was dl by dt, right? So total dl upon dt becomes equal to summation Ri cross F external I plus F internal I. No, it is not. F internal I is not 0. They are distinct forces. They are acting. The force that the earth applies on you is not 0. Just because you are also applying the same force on the earth. It is there.
But the net is 0.
No. You cannot net it like that. They are local forces. They are not shiftable. Don't fall into that trap. How is net 0? What do you mean by net 0? Then does it mean that if I jump from the first floor, I will not be attracted by the earth? No, it is there. That force is there. You just cannot cancel it. Howsoever dearly you want it to cancel, it won't. Don't fall into that trap. Newton's third law of motion, those two forces, they have their independent existence. They cannot be shifted. So they cannot be added in the way that we have been adding the vectors. Otherwise, what should have happened? You go on the first floor, you say that, okay, fine, I'll try to pull that force that I am applying, let both of them sum, and I'll float in air. No, not possible. It will never ever cancel. It is the torque which is cancelling. It is the torque that got cancelled. These two forces are very real and existent. They are there. These two forces have their existence always. They'll never vanish. Forces are not vanishing. The torque has vanished. Don't make that mistake of thinking that the torque has vanished because the force has vanished. Then I would not have done all this. I would have straight away told you that, but that will be an absolutely wrong understanding of Newton's third law of motion. And I have told you that that's why the Newton's third law of motion and the first law of motion, they are not readily understood by us, the Indians. Okay? Because we want an equation, a formula, which it does not have, so it will keep on hitting you. Right, now if someone says that these two sum to 0, it looks a very enigmatic reasoning, but wrong, absolutely wrong. Okay, so it is something like this, and this becomes Ri cross F external I, or I'll say Fi external, no? Fi external and Fi internal. So I say it is Fi external plus Ri cross Fi internal. Now that is equal to torque I external plus torque I internal summation. Excuse me. Now this will vanish due to this reasoning that has been advanced. So which is equal to summation tau I external plus 0 vector, and A plus 0 vector is a 0 vector. So okay.